All right. Hello, everyone. What we're doing in this screencast, we're going to discuss how you can build your conversion factors. I noticed some of you have a bit of a problem when it comes to convert units from one form to the other one, and so I hope that this screencast will clear up a bit your ideas about it. So moving on. Well, the good news is that you don't really need to memorize conversion factors. All you need to remember and memorize is just the relationship between different fractions, or better, the prefixes that you find in different fractions as part of the standard unit system. So if you think about the different units, like unit of mass like grams, or volume like liters, and so on, they all have fractions that do have the same prefixes, which mean exactly the same thing. So if you see, for example, something that has a milli in front of it, whether you're talking about liters or grams, like milliliters or milligrams, that milli, that prefix, means exactly the same thing. It means you're talking about a unit, a fraction of the original unit, which is 1,000 times smaller than the original unit. If you see a microd, you're talking about a fraction of the original unit, which is 1,000,000 times smaller than that. So these prefixes are the same for all the systems that you're talking about. So meters, grams, liters, and so on. And if you don't believe me, that's exactly what we're talking about here. So these prefixes are exactly the same and they have the same meaning. So you're talking about milligrams, you're talking about 1,000th of a gram. You're talking about a micrometer, you're talking about 1,000,000 of a meter. 1 microgram is still 1,000,000, but in this case of a grams, 1 microliter, it's 1,000,000th of a liter. So the prefixes are the same. So if you remember the relationship between these prefixes, what they mean, and their relative value compared to the original unit, basically you're in business. You can prepare any conversion factors that you want. Okay. Now, not only you can prepare a conversion factor to convert the original unit into a smaller fractions, but you can also convert smaller fraction into each other. What do I mean by that? You see in this slide here. So now, for example, you have to convert 1 microgram into centigrams, right? So now you know that 1 microgram is 10 to the minus 6 grams, right? Comparing micrograms to, and then centigrams is 10 to the minus 2 grams. So the difference between them, you can calculate it, right? It will be 10 to the minus 4. So meaning that micrograms obviously is smaller than centigram. The more you move to the left, the smaller the unit comes. So it means that you'll need 10,000, basically, micrograms to make 1 centigram. Right, so that's the relationship that you have in there. So not only you can convert the original unit into smaller units, but also the smaller units into each other by understanding this relationship and the differences between them. Let's go through some examples here. For example, how do you build the conversion factors to convert these units? So you got to convert 7 nanometers into millimeters. What I highly recommend is that whenever you have to do a conversion, you always write the starting units on one end and what you got to end up with on the other end. Once you have done with that, you can build your conversion factor. Your conversion factors obviously will have to have the unit that you want to get rid of opposite to the one you're starting with. So in this case, nanometers will be on the bottom because nanometers is on the top on 7 nanometers, right? And then opposite to that, you will have the unit that now you want to introduce, you want to convert it to. Once you have done with that, now you got to think about the relationship between these two units. What is the relationship between nanometers and millimeters? So nanometers compared to the original unit will be 10 to the minus 9, right? Millimeters compared to meters will be 10 to the minus 3. So the difference between them is 10 to the minus 6. With nanometers being smaller, and therefore you need 1,000,000 nanometers to make up 1 millimeter. So can we write here, basically building a conversion factor, you will need we say 1 million nanometers to make 1 millimeter. That's exactly what I'm writing, what I just said before. And by doing that, I build my conversion factor. So now you have your conversion factor that you can multiply your original unit by. And so nanometers will write off, and then you multiply the numbers there, 7 times 10 to the minus 6 in this case, because it goes to the opposite side, millimeters. Your conversion is done. Let's go through another example underneath. 6 milliliters, how many microliters is that? Let's go back to that. So let's write down what we start with and what do we have to end up with, microliters. So we need now a conversion factor that must have milliliters on the bottom so that you can write it off, and microliters on the top, so finally it's converting to microliters. Now, what is the relationship between microliters and milliliters? Micro and milli, it's here. So the relationship between them is 10 to the minus 3. Microliter is smaller, so you need 1,000 microliters to make 1 milliliter, right? You need, again, let's write it here. You need 1,000 microliters, which is on the top, to make 1 milliliter. You could omit that 1 on the bottom, but again, it reflects the reasoning better by writing it right now. So you have built your conversion factor right there. So you're ready to convert it. Just cross multiply. So 6 milliliters will be equal to 6 times 10 to the third microliters. Sorry, that's a 3. All right. I hope things start making a little bit more sense now. Let's go through another example here. The question is, it's actually a more practical example, this one. What is the concentration in micrograms per liter of a solution which is 9, so let's remove that, of a 9 milligrams milliliter solution. So your starting solution is 9 milligrams per milliliters, right? And you have to end up with micrograms per liters. I think it's clear already that you have to actually do two conversions, because you have to convert the milligrams into micrograms and the milliliters into liters. So you'll need two conversion factors. Let's start with milligrams converted into micrograms. So the first conversion factors must have on the bottom the unit you want to get rid of, milligrams. Sorry, that's a G, I can't write it. And micrograms on the top. So now the question is, how many micrograms do you have in 1 milligram? Micrograms, 10 to the minus 6, milligrams, 10 to the minus 3. Micrograms smaller, so you'll have 1,000 micrograms in 1 milligrams. First one is done. So these milligrams have been converted to micrograms by doing that. Now the second conversion factors. In this case, you'll have to have milliliters on the top. So when you cross multiply, milliliters disappears, and liters on the bottom. So the question is, how many milliliters do you have in a liter? So if this is liters, this will be milliliters. The difference is 10 to the minus 3. So you need 1,000 milliliters to make 1 liter. 10 to the 3 to make 1. Sorry, the pen is going crazy, or I'm going crazy, or the pen is going crazy. It's obviously it's the pen, but for some reason not writing very well. Anyways, I hope it's clear. So the final results here will be 9 times 10 to the 6 microgram per liter. Okay, so in this case we had to build two conversion factors, but again the point is always the same. Whether you have to build 2, 3, 4, 5, in the end the reasoning is the same. Just take it easy, do it one step at a time, build one conversion factors at the time based on this relationship between fractions. Let's go through another example here. Now you have to prepare 20 milliliter of a 10 millimolar solution of sodium chloride. Sounds almost scary, this one, but it's not that scary in the end. It's again, it requires different steps here. So first of all, we got to think about the definition of molarity and millimolarity. This is defined in the screencast on solution and dilution, which you have to watch separately. It's mandatory that you watch before the class. So I assume that you went through that. So you know that molarity, molarity means moles per liters. So this means that millimolarity means millimoles per liters. So when you see 10 millimoles, what it means is that you're talking about 10 millimoles per liter. Okay, so that's the final concentration of your solution. Now, obviously this means that if you have to prepare 1 liter of solution, you will have to add 10 millimoles. However, here you have to prepare 20 milliliters. So what it means is that now, to figure out how many millimoles or moles that you need to have, you have to convert liters into milliliters so that you can cross multiply. So how do you convert liters into milliliters? Well, by using a conversion factor that has liters on the top and milliliters on the bottom. Now again, the question is, how many milliliters do you have in a liter? 1,000 of them. So 1 over 10 to the 3. So this is already telling you that you need 10 millimoles over 10 to the 3 milliliters. So now you can figure out by multiplying this by the total volume of your solution how many millimoles you will need to measure on a balance, basically, to get your final concentration, to make your 20 milliliter solution. So you have 10 millimoles times 10 to the 3 milliliters times 20 milliliters. This would give us 200, so 2 times 10 to the 2 millimoles over 10 to the 3 milliliters. Now we can start simplifying here a little bit. So this will be 10, so this stays 10. So it will be basically 0.2 millimoles. And this milliliter is gone, obviously, because we cross multiply. So that's what you need. Basically, you need to measure 0.2 millimoles. Okay, now, how does that translate into grams? When you use a balance, you don't measure moles or millimoles. You measure grams. Now you have a conversion factor that in this case is given to you, which is the formula weight of the solid you're using, which is sodium chloride, which is 58 grams, 0.44 grams per moles. Now, in order to convert these millimoles into grams, you can multiply by that. The problem you have is that this refers to moles, not millimoles, meaning that this now, millimoles, has to first be converted into moles before you can multiply by that factor. So, how do we do that? 0.2, how do we convert that? 0.2 millimoles can be converted into moles by multiplying by another factor. You can see you can build any factors you want here. Millimoles, a factor that has millimoles on the bottom and moles on the top. Okay, what is the relationship here? So moles will be here and millimoles will be here. Milli, same prefix. So you need 1,000 millimoles to make 1 mole. So 10 to the minus 3. What the heck did that come out that? So that's a 1 on the top. 10 to the minus 3 on the bottom, 10 to the 3, sorry, plus 3 on the bottom. So it means that 0.2 millimoles will be equal to 0.2, my gosh, this computer is driving me crazy, my apologies, but 0.2 times 10 to the minus 3 moles. Great. Now that's what you need to measure that can be converted into grams by multiplying by the formula weight, another conversion factor, which in this case is given to you, which tells you what is the mass of 1 mole of sodium chloride, which is 550 58.44 grams per mole. This will give you exactly the mass that you need to measure in order to prepare 20 milliliters of this solution of sodium chloride. I'll let you do the last step on calculation, and so we can move on to the next example. All right, let's go through one last example here. In this case is, okay, what mass of sodium chloride do you need to make 0.050 liters of a solution that has a final concentration, which in this case is not expressed in molarity or millimolarity, but it's expressed in percent weight over volume. This concentration too is explained to you on the screencast on solution and dilutions. Well, we know that percent weight over volume means grams of solute over 100 milliliter of solution. So this means that this corresponds to 0.8 grams of solute, sodium chloride, per 100 milliliters of solution. This means that if you have to prepare 100 milliliter of a solution of sodium chloride at that concentration, you will take 0.8 grams. In this case, though, you don't have to prepare 100 milliliters, but you have to prepare 0.050 liters of them. So, as you can see now, the units here are milliliters, there it's in liters. You have to convert one into the other one. Let's convert milliliters into liters. So how do you do that? You do that by multiplying by conversion factors, which again you can build, that will have milliliters on the top, so you can write it off, and liters on the bottom, so that it will convert into liters. Question, how many liters do you have, how many milliliters do you have in 1 liter? 10 to the 3. So you have 10 to the 3 milliliters, which is the smallest unit, in 1 liter. So which means that you have 0.8 10 to the 3 over 100, which is 10 to the 2 grams per liters. Now we can simplify this by removing this 10, so it will become 10 grams per liter. This is the concentration. This expressed now no more in percentage weight over volume, but as grams per liter. So you have 8 grams per liter. Now it means that if you have to prepare 1 liter, you will use 8 grams, but you have to prepare 0.05 liters. So if you need 8 grams to prepare 1 liter, how many grams, how many times do I have to redo this? How many grams would you need to prepare 0.050 liters? I'm writing a reasoning here. I hope you can see that. So what it means that now the grams that you need to make 0.05 liters are equal to 8 grams multiplied by 0.050 liters of grams per liters. You can do the math on what you need there, okay? It's fairly straightforward. It's 0 grams, 0 grams. Actually, we can write as many decimals as we can here, so it will help with the analytical balance for the measurement. That's what you would need to measure to prepare this mass, to prepare 0.05 liters. Again, you can see how conversion factor help you in this real life question as well. I hope that all of these actually will help you to understand really the importance of conversion factor and how easy ultimately they are to build, as long as you understand again the relationship between the fractions, which is always the same no matter what unit you're talking about there. All right, hope this helped. I'll see you all in class.